Hello again. This is the third and final lecture video that deals with the test review. I wanted to go over number 8, which is our rational inequality. Now, when dealing with a rational inequality, we're still talking about the regions where the function is above or below the x-axis as listed here. So here we're looking for regions where this function is above the x-axis. So now for your strategy, you want to create a number line with all of your zeros, your intercept points, and any places where the function is undefined. And we're going to look at the regions between those things. So if I were to consider the domain for this first, then looking at the bottom of the function, I have x minus 1, so x cannot be 1. So my domain here is from negative infinity to 1. And from 1 to infinity. So the first thing I'm going to put on my number line is 1. That is a value where the function can change from positive to negative or vice versa. Looking at the other part, places that are zeros or intercepts, those come from the top of the function. So x plus 9 times x minus 7 equal to 0 gives me x equal to negative 9 and x equal to positive 7. Those are the other two values I'm going to put on my number line. So I have negative 9 here and positive 7. Now I have to think about whether the function's positive or negative in each region. I'm also going to put a red line here, and you can express that as an open circle or however you want to do it, at 1, because that number's not in the domain, which means that if I'm looking for regions, I can never include it. So I'm going to pick a test point in each of the regions. So let's say we use negative 10 and negative 4 and maybe 2 and a test point of 10. Now, like we did when we graphed rational functions, we're just seeing the sign of the function during this region. So if I were to plug in negative 10, negative 10 plus 9 gives me a negative. Negative 10 minus 7, also negative. Negative 10 minus 1, also negative. So the whole thing in that region is negative. So I'm just going to notate it here. For negative 4 plus 9 is positive, negative here, and negative on the bottom. 2 negatives give me a positive value, so this region right here is positive altogether. Next point is 2. 2 plus 9, positive value. 2 minus 7, still negative. 2 minus 1 gives me positive. 1 negative is negative, so this region overall is negative. And the last region, 10 plus 9 is positive, minus 7, also positive, and positive here too. So now that I've figured out where my regions are positive and negative, I'm going to decide what I need. So looks like greater than or equal to 0. So I'm looking for the positive ones. And the regions would be this one and this one for positive values. Now I can never include 1. 1 is not in the domain. So if I'm looking for x values that make this thing positive or 0, it includes negative 9. Negative 9 would make it 0. That's a 0. But 1 is undefined, so I would not include 1. And then from 7, 7's a 0, so 0 is okay. And this ends at infinity. So I have something like that. So my answer would be from negative 9 to 1. But 1's not included, so a rounded parenthesis at 1. And from 7 to infinity. Those are my solutions. Now, one other thing to note, and this is not on here, but one other thing to note is if you're going from a rational function's graph, you don't have to do necessarily all of this work. So let's say that I have already graphed out a rational function. And here is an asymptote, here's an asymptote, and I've got one here as well. And I have my function itself, and I'm just drawing this kind of randomly. My function itself looks like this. I've got a positive piece here. I have a 0 here, comes in from the bottom, looks something like this. And let's say we've got another intercept point here, and it looks like this. Now this is my function f of x. So if I was asked where f of x is greater than or equal to 0 in this case, and I've already done all the work in order to graph it, I don't need to reconstruct the line. All I need to do is look at the graph. So looking at the graph, I'm going to highlight in red the places where it's greater than or equal to 0. So it's greater than or equal to 0 here, because it's above the axis. It's greater than or equal to 0 starting at the intercept point and heading this way. And it's greater than or equal to 0 starting at the intercept point and heading this way. Now we still have to convert that into an actual interval. So remember, we can't include the asymptotes. So I would have from negative infinity to whatever this asymptote line is. Let's call it x is equal to negative 4. And x is equal to 3. So, and then I have from this 0, we'll make that x is equal to 1, now the Java scale, to the asymptote line, but I can't include the asymptote. And then from this 0 and to positive infinity. So if I were to draw up the answer just based on this graph by itself, then I have negative infinity to negative 4, and from 1 to 3, and from 5 to infinity. All right, remember that we have an extra review tomorrow, or not tomorrow, my goodness, I won't be here tomorrow. We have an extra review on Sunday, which is the 19th from 2 to 4 in the afternoon. So feel free to come in, bring your questions. I'm not going to teach, so you will have to have questions on the review. Now, if you haven't actually worked the review at that point, then just bring your review, come in and work on the review, and I'll answer questions as they come up. So that is Sunday, starting at 2 o'clock, building 4, first floor. All right, have a great day.